Yeah, just to say that I was a brand new weed science guy as 1994 when I started at Texas A&M, and the brashness of the time of the company that shall not be named at that time to the weed science community was palpable for me, and I used to work for them as an intern. And I thought that was actually kind of fun, but then they were a different company by the time I went to grad school and got out as a faculty member and became more of a life science outfit. And I remember thinking, well, they're really not even involving the industry, or I'm sorry, the industry was not involving the academics very much at all. It was an end around kind of a situation. And that to me was my introduction to all of this in really 95, 96 when this technology came out. But that's what hit me the most, because I think most of the older weed scientists who were walking around at that time were going, this is a bad idea. We know how to steward this stuff, but that's not what the market was going to bear. And that was really how it went. But anyway, well, let me throw some really other good news at you. I've taken some slides here from Ian Heap just to give you a little bit idea about the issues with weed resistance, and then I'll talk a little bit about some things related to both post-emergence control and pre-emergence control. A lot of what I'm talking about here is obvious trends that could and probably are related to some sort of climate change, but to really pinpoint it, I think Jim said it yesterday, to really blame all of that on climate change really hard, because we've exacerbated the issues, and I'll talk a little bit about some of that as well. But just to start off, we got a slide here from Ian Heap, our colleague in Australia, has done a really good job of compiling a lot of weed resistance data. And what we got here is a number of unique resistant cases over time, starting in 1950, all the way up to really 2021, where it's ended here. Over 500 unique cases. Obviously, in the early 70s is when we started to see this trend upward, and it's continued to go upward. And I suspect it will also continue to move upward until we run out of weed species. We also have a number of weed species here for several different herbicide mode of actions. And the two that are the highest as we look at 2020 are the ALS inhibitors, or HRAC group number 2, as well as the EPSPS, which is HRAC9, and that's glyphosate. You can tell in the early 70s when glyphosate was introduced, there were no cases. It showed a little bit of an upward trend in 1975, but really nothing of particular significance. The 90s really exacerbated that a little bit further. And so the other species, or the other herbicide actions there, fairly small numbers in relative to the ALS inhibitors and the glyphosate materials. Both instances, and I want to point this out because I think this is important, the synthetic auxins, ACCase, the HRAC9, the glyphosate there, ALS inhibitors, all post materials. PS2, which is atrazine, could be used post as well as pre, but the real big cases that you see there, the high ones, are the post herbicides, which again is the trend that we see more post-emergence applications. We're look at these numbers in the various countries. United States, we're number 1. I'm not sure we should be proud of that. There we are. Europe is number 2 with a number of unique resistant cases. Australia is followed by the 3rd, and a couple other countries below that. And when we look at the different crops, wheat leads the charge with a number of unique resistant cases, and then followed by corn, and then soybean is soon behind it, rice very close behind it. If we look at the issues related to weed species with more than one side of action showing resistance, we have some of these weed species that obviously are really robust. Some of them have 11 resistance to them on different sites of action. That's incredible. And we look at the number of over 100 have at least two. So obviously there's changes going on out in the environment. There's things that are being selected for, and this is obviously a trend that's pretty brutal. All right, so increase in glyphosate resistant weeds, and Marty showed this with a little bit more detail earlier. Obviously we're doing great till 1995, 96, when guess what? I think you can mark the introduction of glyphosate resistant soybean at that point. Soon after was cotton. And then we started to get more of these number of species that were resistant to glyphosate. So the idea that silver bullet was there, oops, not so much. And the other thing I think is also interesting, I think Marty showed this one as well. We've really had a period here of more than 30 years where we really didn't have any new modes of action. I'll talk a little bit about the reasons behind that a little bit later. But obviously, without any new chemical tools, we have to look elsewhere for some of the issues that we're trying to solve. How about some of the different herbicide actives and some of the different species that are resistant? Atrazine actually leads the charge here, but atrazine's been around a long time, used both pre and post, like I said. Simazine's also on that list a little further down. Those two materials are really the only two of that list that would be considered the pre-emergence herbicides. Can be used both. But everything else on that list is post, okay? And most of them are the imidazolinones or the sulfonylureas, which attack the ALS mechanism. And a lot of those were created in the 80s, almost all at once. They're really easy to get labeled. They're really environmentally safe. And there was just a big pile of those that were created and kept being created, which was kind of cool. Except, and the other cool thing about those, some of them worked on grasses, some of them worked on sedges pretty well, and some of them worked on broadleaf. So if one didn't work for your weed problem, you could get another one to do it or mix them together. Except the problem was they were working on the exact same mechanism. So that was an issue that created a lot of the resistance issues that we have shown a little bit earlier. Different weed species that have multiple sites of action of resistance. See a list of those there. Lolium rigidum is one, Echinoclocrus galli. We've got Amaranthus palmeri, Palmer amaranth, and I'll talk a little bit about that one. Some of them obviously have a tremendous robust ability to get through multiple sites of action. Well, you could blame this all on climate change and just looking at that data right there with the average temperatures going up over the years compared to the mid 20th century. Certainly there's some trends there that really fit, but we are exacerbating the issues by the way we manage weeds and really the climate that we're in. I'll talk a little bit about a couple of other things that are related. What's some of the stuff about pre-emergence herbicides? This is some data from Jason Kreutz when he was at USDA, former student of mine. And one of the things that we're also dealing with is things like atrazine that's been really good and useful for so many years. The thought was maybe it's not working like it used to. So if you look at an adapted soil, which is the solid line, and a non-adapted soil, which is the dashed line, the half-lives of the amount remaining over time are substantially different. So if you repeatedly apply atrazine over and over, then the microbial population gets used to that and they're able to figure out how to break it down better. They have those mechanisms, and then all of a sudden we're not getting the kind of stability from that molecule that we had before. And then it goes away faster and it's not providing some of the weed control. So if you combine that with a little bit warmer soil temperature and a little bit more microbial activity, all the things really get accentuated. So we got that going for us. How about a little bit about some moisture? And I think Marty alluded to this too. This is old data. But influence of rainfall and activation of two group 15 herbicides, asfotolachlor and acetochlor. This is from 1967, but Bob Hartzler put it out there on the web. And I pulled this up and thought it was a good example. Well, you look at this and they go, well, why don't some of these people just go ahead and put pre-emergence out? Great idea. But if it doesn't rain, you're going to get half the control for giant foxtail. Even a tenth of an inch doesn't really add much to it. You start to get a quarter inch and you get a little more, but you need about an inch of rainfall to get this stuff activated, and then you get really good control. In these day and times with drought or with really heavy rainfall events that wash it off, can a producer who's now paying a technology fee for glyphosate that doesn't work very well anymore, still has to pay the technology fee, would they go ahead and roll the dice on a pre-emergence that may or may not work for them all that well? The thing is, it still provides some control, but is it good enough? Contributing factors to some of the inconsistent results. The other thing I think too, when we start talking about pre-emergence herbicides maybe not working like they used to, metolachlor is an example. We now have metolachlor-esque. It's really a compound that is applied at a lot lower rate than it used to be. It's a little more active than it used to be because we've chosen the S portion of that molecule, but the rate is a little bit lower. So when you get a rainfall, it may have some inconsistent results because the load that's out there in the soil is not great. Atrazine's also, I think, maybe applied overall at a little bit lower rate than it used to be. So those, when you combine that with some no-till, reduced tillage programs where you're absorbing or adsorbing a lot more of that material, it effectively is a lower rate. So you combine that with a little bit more, I would say, degradation, faster degradation because of repeated applications, then we've got a lot of issues. Certainly weed shifts and competition have changed along with that. But then we have producers having a behavior issue. And I think we talked a little bit about behavior yesterday. Short-term economics versus long-term stewardship. Some of these folks are farming on property that's not theirs. We have landowners that are absentee. They don't care whether or not you are stewarding this material or not. They want to make money. And so there's that. So also looking at the pre-emergence application, was it going to work or not? I got to spend money to do it. Will it work for me? There's a question mark. I'm already paying a technology fee for all this other stuff. Maybe I don't do it. And they're really trying to make sure they make money that year rather than stewarding it long term. So all of those things are contributing. Let's talk a little bit about post-emergence. Obviously, a total post program. A lot of these really programs started with ALS herbicides, but it was really even further exacerbated by Roundup Ready technology. Worked great for a minute, but then when we start looking at issues, just statistically, if you look at the picture on the left, and we're going to go with a total post program, that's putting so much pressure on a post-emergence herbicide. And then we start thinking about the environmental conditions that have to be just right. By the way, the post programs for glyphosate as well as ALS herbicides, and many of them are related to phloem mobile herbicides. Phloem mobile herbicides are systemic. That means if the weed is growing really robustly and we get a lot in there, we got a good chance to control it. If it's in a drought condition or stressed in any way, it does not absorb as well. We do not get as great a control with it. And then all of a sudden we got problems. If you look at the right is a pre-emergence application, worked really well. The statistics for us to actually do a really good job of controlling that season long are really good. We got two different mechanisms we're using, or two different kinds of weed control programs that we're incorporating. It's not really hard to figure out which one's easiest, except one's more expensive than the other. And so we got that to deal with. So contributing factors for inconsistent results of post-emergence. Again, trend toward total post. That's okay if you have a fairly small field to deal with. Maybe you can get those weeds when they're really short, like you're supposed to in the window of application like it's designed. Except that's usually not what happens. We in Roundup Ready technology years, what we've created are farm sizes that are getting bigger and bigger. And now we have a window of application that's supposed to be in a 4 to 8 inch size for weed, except now the producer can't necessarily get over all that at the optimum stage. So then we've got those issues. So to me, farm size has become a little bit of an issue. Extensive use of ALS herbicides, extensive use of glyphosate, again, over the top, where it's a total post program, put a lot of pressure on our technology. The environmental conditions or weed size are less than optimal. And then we got an agronomic area that's a little too large for management needed. We could talk about dicamba. I put 3 dots there. I don't want to talk about it. It's one of those things, another flow mobile herbicide that has a lot of other baggage to it, that created drift issues that theoretically weren't going to happen. Again, that was pushed by an industry that had an idea that they could fix something in a similar way that they used glyphosate. And it just really was not ideal and never has been. I'll talk a little bit about weed competition real briefly. If you haven't seen something like this or heard about it, methicillin resistant Staphylococcus aureus. Why did I put that up there? It has nothing to do with weeds, except we've created the MRSA of weeds, in my opinion, with something like Palmer amaranth. When you get rid, a microbiologist friend of mine talked about this with me one day, MRSA is not a real problem out in the world in general outside. But when you get in a hospital and you clean everything else off, and then you have MRSA, then it's a problem. And so in a lot of ways, what I think we've created with Palmer amaranth is this ability to almost isolate it along with everything else. Everything else has almost been gone. But now we have something that has a rapid growth. I would say probably more like 4 inches per day of growth in full light, 500,000 seeds for one plant. It can germinate over a very wide range. Obviously resistant to multiple classes. I think it's 8 from the graph before. Really high water use efficiency and very adaptable. So lots of things have occurred. And if we talk a little bit about a wicked problem of herbicide resistance that parallels antibiotic resistance, you've already alluded to this. Group 28 of the herbicides that we have was just really introduced in 2021. That was the first one in about 30 years. And so we haven't really developed a whole lot of new ones. Last class of antibiotics discovered was in 1984. And so they got a similar issue, and it's a health problem. And so I would argue so is ours. Why haven't we created more? Well, and this data is really 10 years old, but really we're looking at about 300 million plus to invest in a new active that goes from discovery to label. And that's if a plant's really needing to be built, that might even get a lot more expensive than that. The chances in 1994, mid 90s to get a chemical to label is about 1 in 20,000. From 10 years ago, it's really 1 in 140,000. So the chances have become less and less. And it takes 10 to 13 years to profit from the sale of that chemical for that group that's created it. So a lot of issues there. Contributing factors along with climate, crop rotation versus short-term economics. We know, I think, in a lot of ways, just to take us back to the Shire after taking a Mordor for a while, we kind of feel like there's a lot of technology that we have, even from a beginning weed science book that we would give to a senior in college to study this stuff. We have a lot of tools, crop rotation being one of those. But if you're looking at short-term economics and have to deal with that, it may or may not come into play. So academically, in a lot of ways, we know how to do this, except the practice is very difficult to get a producer to do. Timeliness of applications. Again, if we get these later on a total post program, we're going to get some breakthroughs and resistance will be selected for. The farm scale enhances that even further. And so if you can't get over that whole area, then obviously we've got issues there. Chemical mode of action rotation is another thing that I think we've known about. It makes it a lot more complex. And so we can use that term again. We've heard that this morning versus using that very same program that everybody's known about from year to year. And then we got deals at the co-op. So those are the other cool thing. So the co-ops that sell these materials might have a deal for a producer. Well, if that's the case, then maybe they're gonna go with that same mode of action they had year before. If it's cheaper, right? And then you combine that with a few other things and then all of a sudden they can make it cheaper, but long-term effectiveness or stewardship is out the window. There's always that expectation that a new technology is gonna fix the problem for the producer. It's just becoming more challenging. And really ultimately no long-term stewardship as a viewpoint. That's really what we need right now, and that's just been gone. I'll mention this since my colleagues are here, Rick and Jeanette have been involved with this. I think this whole meeting's really good. It's one of those things I think bringing light to what we really need to do is push for funding and have good reasons for that. We have this document here, a piece of it from Ag Innovation Research Roadmap of 10 years. We've got three big pillars there: workforce development's overshadowing that, but also national security is a part of that whole thing, but certainly food systems and climate solutions are a big part of what we're talking about here. And that all fits under some national security issues. So thanks for the colleagues that have been pushing this, Jeanette and Rick. That's it. Thank you.
Very good. Questions for Scott?
If I might just follow up, Scott, you mentioned cost. And Marty, I heard you say that need for innovation. I just want to take a stroll down memory lane for a moment, and that is investment in publicly funded agricultural R&D has diminished dramatically over the past 2 decades. The United States currently is behind China, is behind the European Union. We expect that we will be behind India and Brazil in the next 2 years with respect to publicly funded ag R&D. So there's clearly a clarion to invest in ag R&D. I've heard you also, I've heard complexity frequently. I appreciate that. I've heard a need for building databases and harmonizing data, building surveillance and diagnostic systems. Investing in innovation, diversifying our weed management strategies. And so as we in Ag Innovation, your experimentation directors, are advocating for funding for you, what's your number? So as you sit back and you look into your crystal ball, you said, if we had X, we could get to where we want to go. What's that number? And I know that that's putting you on the spot. You may not be in that, well, hell, I haven't done I haven't done the math. But is there a ballpark figure? Because these are wicked big problems. And the one thing, the common denominator that I hear my friend Mike Hoffman say is that we all eat. Across the globe, we all eat. This is not a partisan challenge. This crosses all aisles. What's the number that we need to have to be able to address these problems?
Sorry, Scott, you want to take that?
Go ahead. I got a big number.
I'm just saying, I won't be able to answer it. I mean, I don't know the number, but what I do hope what we could do, this paper we're working on right now, is at least for a certain parameter, certain slice of agriculture, the cost if we don't.
Right.
Like what's the, and come up with that number, because I feel like we can, just being a, empirical guy or quantitative, put a cost on that, and then does that guide us in, well, if we don't, here's what, if we do nothing, here's what we're on track for. So, well, what's it worth? And I maybe it helps get to that number.
Well, I think that Marty, it absolutely does, and those counterfactual studies are few and far between. So if you've got that note, I'd be interested in hearing that. Work on it.
Jeanette, you want to tell them a little bit about the number we've kind of landed on?
Sure. So this is a platform for discussion, right? So we want to have the Jim Stacks and the rest of you in this room go to the Hill and speak with members and staff members and say, hey, in order for us to solve these three big areas that are societal challenges, right? So in climate, in food security, and in water resilience is the roadmap, what the roadmap is around. We're just asking for 1% of the total federal R&D. And that one, in addition to what we already get from USDA and NIFA, I believe the total ag funding that comes to LGU is right around 1.7 billion per year. So we are asking for an addition of 1% of that total federal R&D. That total federal R&D is about $193 billion. So we're asking for an additional 1.9 billion per year to tackle these big, important societal issues.
Like that, so the number's important, but so is over time.
Yes. Right on.
You're not looking at a check, you're looking at an investment, as I think the term was, and that's got to be carried out over. These are not simple challenges to address, and they're not going to be addressed in 2 years. These are going to need to be addressed over a long period of time. So the commitment has to be there that if you start down this road, that you're going to ride the car all the way to the end. And that I think the problem is, I don't go to, I would speak for myself. I don't have the confidence of that continuity part.
And that's where I think the whole idea behind the Ag Innovation Group getting together is to create a long-term, just urgency that we need this. It's not we want it. If in a perfect world, if we had this, we'd be okay. No, we need it. That's a little different tone, and I think we really need to start saying those words.
And we have allowed ourselves to fall so far behind. We have road we have to catch up on.
Yep.
Yeah, absolutely. And as we think about that, as we think about innovation, there's clearly a lag time between innovation and adoption. And that, to me, Jim, is where you've got to draw the line in the sand and say, we need investment over time. It's not a one check deal. It's a many checks.
If I could just add to this, put it in perspective on this really good book. There's a little data, but in 2015, ag research and development total, the investment of federal government was $4.5 billion. That same year in the US, we spent $43 billion on video games, accessories, and associated hardware. That's what
Touche.
can help us eat.
Touche.
And NSF and NIH
Yep.
certainly
Yep.
eclipse what we have been able to get.
Neil,
Neil McRoberts, but I'm going to defer to my colleague Alison Smart, who also had her hand up a moment ago. And then if she doesn't say what I'm going to say, then I'd like to come back.
I might be saying the same thing you're gonna say. I obviously don't have an answer for that, but I can say that NPDN as a whole has come up with a number, made it in Excel with all the justifications of it, given it to Amr, dispersed it, talk about it, and that's 15 million. We currently get 3 million a year. And as you hear, we are not where we need to be.
Right.
And
So that's sort of the point I was going to make, and if I can follow on there, I was going to make an optimistic point here. Using NPDN as an example, and this comment's in the document, but I'm going to say it out loud anyway. Not that I would normally put NPDN forward as a stunning example of a program that gets all the support it would like, but for $3 million a year, what happens is a bunch of people turn up. It keeps us invested in solving the problem. It's enough. And this goes to the comment that Art, I think, made yesterday about continuity of this program. Small amounts of money in these areas, that any of the tactical sciences programs illustrate this point. Small investments added marginally to the infrastructure that's already there can make a huge difference in terms of keeping people focused on the issue and at least willing to turn up and try and do something. So an extra billion would be fantastic, but we can do a lot with a lot less if it's used well.
I only kind of agree with that. So 2 points. One, that figure 15 million, don't forget, was in 2017. Okay, a lot has happened to the purchasing power of 15 million cents. So, 15 million, yeah, it'd be great to get that. But we're already behind the curve to realize what was put into that spreadsheet. The other thing is on the getting by on a little bit, that creates a false sense of security. If you under-resource these programs, you can say, yeah, we're taking care of business, but you're not. So they have to be adequately resourced if you want to realize the objective, the goal. And we don't do that. We throw a little bit of money and we say we have a program, so we're taking care of. We're not. When you under-resource something, it creates a false sense of security. I think you have to guard against that. Yes, I'll take what we can get.
See what we can
I
do.
really appreciate the national security.
Yeah.
came up. I brought that up at the very beginning of this meeting, that what we're doing is really national security.
Right on.
And to do it well, we're gonna have to fund it. So figuring out what that looks like and coming up with some recommendations for what needs to be done makes it easier to hang a dollar figure on it and not just saying, give us $1 billion and we'll go out and do some stuff. We need to peg it to where the needs are.